talk a little bit more about how we measure biological exposures. If we think about the overarching framework for how we measure any exposures, these could be chemical, physical, or biological. We think about this as falling into either direct methods or indirect methods. Direct methods, we are going out and getting a measurement, right? We're either doing biomonitoring, so we're taking biospecimens. This could be blood, this could be urine, it could be saliva, it depends. Or we might do personal monitoring, where we are looking at what is the exposure, for example, in the breathing zone, or at some point of contact for that worker. With indirect methods, we may be doing more ambient environmental monitoring that is not specifically tied to work activities or a breathing zone, but generally in an area where someone is working. Or we may try to reconstruct exposure using questionnaires or diaries or other methods of recall. Measurements can also use existing data, and some of this can be tied into requirements that might be regulatory, although there are not that many requirements in terms of the biological exposures, unless you work in particular, like in a laboratory where you are working with biological agents, and there may be a process for how you do that work under biosafety laboratory conditions. Certainly, industrial hygienists and other occupational health specialists may collect their own data. Some of these data could feed into models, whether they're deterministic or stochastic. And we can also use things like remote sensing and feeding data into geographic information systems to help us understand exposure. We might need to go back and try to reconstruct exposure. For example, if we have a health event that triggers an exposure monitoring process, we may want to think about, well, how did that actually happen in the first place? And so some of this can also involve qualitative work, whether it's questionnaires or you're asking people about the duration of the exposure. You're looking at different job titles where you might have higher or lower risk for exposure. And again, you can do your own data collection and do biomonitoring. Again, urine, serum, exhaled breath, there are a lot of different ways to collect biospecimens. If we think about different kinds of monitoring, we might think about ambient monitoring, right? So air monitoring, water monitoring, potentially in soil or food, although I'll say air and water tend to be a little bit more typical in an occupational setting. But if we get into biological monitoring, we're thinking about biomarkers of internal dose like toxins or metabolites, or biologically effective doses. We may be looking at DNA or protein adducts. And this is true, for example, for some kinds of viruses. You can find this, especially in an occupational setting, be looking for biomarkers of biological effects, such as the immune effects. You may be looking at immunoglobulins, so IgG, IgM, in order to understand what the host response is to an exposure. There may also be genetic or enzyme changes that could be important here. And as we move from ambient into biomonitoring, this has increasing significance for health. But of course, the most significant would be clinical surveillance, where we're looking at the health effects. These would be reported symptoms or biomarkers of disease. Of course, the challenges with focusing strictly on health effects is that you don't have the opportunity to see the more early effects or understand things that are subclinical. So with biomonitoring, we're looking at measurement of the agent or metabolite in any biological fluid or tissue. And this has a lot of advantages. It can account for many different routes of exposure. For example, it doesn't matter if you're exposed in the GI or the respiratory system. If you see that there is seroconversion, meaning that someone has immunoglobulins to a certain infectious agent, then you know that there was exposure. It can account for the difference between the concentrations you might find in the ambient or even, personal airborne environment when PPE is used. And so this means that if PPE is beneficial, if it's being used properly, then you may see lower exposure according to your biomonitoring profiles. And it depends, but you can sometimes consider longer term exposures. And then this can account for differences at the host level. I will put a caveat on this because not every infectious disease agent will actually have an immune response that you can measure over the long term. So an example is with SARS-CoV-2, the virus responsible for the COVID-19 pandemic, we recognize that, especially with some strains, that the immunity can wane very quickly. And so you can see decreasing titers to that particular agent, and that you have also the complexity of having vaccination. And so what you measure would need to differentiate between vaccine-based immunity and natural infection. And there are ways to do this. Conversely, there are some vaccines that lead to pretty stable immune response, and that stability can even persist for years and years. And one example is rabies. Although rabies vaccination does have some individual variability in terms of the length of titer for the vaccine. Some of the disadvantages of biomonitoring, figuring out exactly when to do the sampling can be challenging. And again, comes back to this question of half-life. If we did a sero study today and we're interested in the very first SARS-CoV-2 strain, we're probably not going to get a very good response because most people will already be outside the window of the duration of their immunity to that. And it can be really challenging to take that and then relate it back to what the occupational or environmental concentration was, especially when we consider infectious agents that may not strictly have just occupational exposure, but may also have exposure in the community and through other dimensions of a person's life. And the individual differences can be quite substantial, and this may lead to an inability to really interpret the findings. Finally, participants may be more or less willing to provide samples. So if you need to do a sero study, that involves a blood draw, and not everyone may be interested in allowing for their employer to have blood drawn in order to have their titers tested. There are some more novel methods that may rely on things like use of saliva in order to do the testing, including for immune response. And so it just depends on the exact agent and what it is that you're trying to do. We have to think about, too, the differences between individual versus ecological exposure assessment. And so we might consider individual exposure assessments as the gold standard, but they can be expensive and infeasible because it may cost a lot of money to do this kind of testing. And you may have a lot of variability, especially if your job titles are quite different and the kinds of exposures are very different depending on job title. But the estimates we get tend to be more precise coming out of these kinds of assessments. Ecological assessments, where you're thinking about entire groups of people based on a job title or a common activity, may be better if you want to do a larger study, but you have to understand that the estimates may be less precise and less prone to attenuation. So if we are doing personal exposure assessment, then we're thinking about this for an individual, accounting for where the individual spends time. And so this often requires use of personal monitors that can accompany a worker across tasks and target relevant routes of exposure. And sometimes we can use this to track location. So you might put a location tracker on a worker and then have ambient monitors for environmental exposures. And then you can partition the amount of time that a worker spent in location A versus location B. And then there can be other kinds of monitoring that will be cumulative, such as the use of wristbands. Now, what I show here in this image is a worker who's doing sampling of a pig. This is a cute little piglet, and there is a button sampler on the lapel that's capturing the breathing zone with an interest in occupational exposures to things like livestock-associated Staphylococcus aureus and livestock strains of influenza. These would all be important for a respiratory route of exposure. So what is the breathing zone, right? This is very important for our respiratory problems. So the breathing zone is that zone within, about 0.3 meters or 10 inches of a worker's nose and mouth. And with this, we have to make some assumptions that we don't have variability in terms of the infectious agent within that zone. But this really does help us understand what might be coming through the nose and into the lungs or into the mouth with open mouth breathing. And so you can see you have a sampler in that same location that I showed for the button sampler on the hog worker, showing where you might take the samples in order to capture that breathing zone exposure. And here's just another example of work activity related to sampling, where the pump for the button sampler is worn in a backpack on the back of the worker who's conducting an activity. And so this was personal air sampling to capture exposures specifically during milking on a dairy farm. And the button sampler is in the front in that location to capture the breathing zone. So just an example. Whereas area exposure assessment is really monitoring that might be conducted at a central portion of a space. In the image shown here, this was ambient sampling for livestock-associated Staphylococcus aureus, and it was located at the ventilation exit point for the building. And so trying to capture an integrated sample across what was happening within the barn where hogs were being raised. And so you can see the auger plate on the impactor sampler here. This is really looking a bit at a microenvironment because you have one specific barn within the large structure of a hog production facility that has multiple barns. And so it was trying to assess the exposures within that particular barn. You then might have to make some assumptions that what you capture out of one barn would be similar in other barns, which may or may not be a good assumption depending on the workplace. And of course, there are these other techniques for exposure assessment, thinking about questionnaires, self-report. You might have an expert judgment process. You might use job exposure matrices or consider occupational history.